So I have a big project for ethnic studies due soon, so I may need to hold off a tiny bit on the beams, but I'm also not gonna do the intros as well. So you know the drill. Just pause the video and read the problem before you start to watch this video. So the astronauts are oscillating or just moving or just shaking, aka moving in a wave or some sort. Uh, so that indicates that the astronauts are in motion. So that would mean we would have to use Sir Isaac Newton's second law. Luke used the mass times acceleration. So since we're looking for the force, we have to get the mass times acceleration since the astronaut's in motion. So we are given the mass, which is 75 kilograms, but we are not given acceleration. So but we are given a position. So if you remember your calculus, you would remember that position derivative of position is velocity. Derivative of velocity would be acceleration. So as depicted here. So to simplify this parenthetical conglomeration, I did it for you guys. So it's 0.30 sine pi of t. And then remember, you have to use both the product rule and of the differentiation and the chain rule massacre for this one. First, you have to do the product rule. So that'll be the first times derivative of the second plus the second times derivative of the first. The second times derivative of the first would be zero. So we don't really need to care about the second part. But the first part is it would have to be zero. It would have to be 0.3 times pi cosine pi of t. Why is the pi outside? It's because you have. It's because it's because of the chain rule massacre. You have to get the derivative of the inside and then multiply it by the whole function itself. So that's why the pi is here. So so anyways, now you have velocity, but we don't have acceleration yet. How do we get acceleration? Since we're only given position and velocity, you can do the kinematic equation and plug in one for t, and one with or 1.5 if you're doing b already, or speed run, and get acceleration by differentiating velocity. You can differentiate velocity by again needing the product rule and the chain rule massacre again. So so yeah. Anyways, the differentiation of velocity or the acceleration function would be negative 0.3 times 2 pi sine pi of t. Remember, in this instance of the product rule, the second part of the product rule will be zero, so that gets off. Anyways, but remember, don't forget the sneaky negative and and yeah, because the derivative of cosine of whatever's inside is equal to negative sine of whatever's inside. Uh, time also times the derivative of whatever is inside. So yeah. But anyways, here's your acceleration function, and now for a we are given two different times, so we're gonna solve for a first. So we have to plug in one for t. So yeah, and now you do the calculations, and uh, and then you would get negative 0.1038. Hold up. It was at this moment he knew. He if you are using radians, yeah, use radians, okay? Not degrees, or else you'll fail your quiz and disappoint your family. Okay? Okay? So now that I have to get that out of the way, if you plug in one for t, since we're given 1 second for part A, and plus your calculator is in radians instead of degrees, you would actually get zero. So I mean, the side of pi radians is zero, so that would just make the whole thing zero. So now you have acceleration at t equals 1 second, so that's zero, and multiply that by the 75 kilograms aforementioned, and you get and you get 0 newtons. And then for the second part, part B, you have to plug in 1.5 seconds. So I already did that earlier. I on my calculator, and it says 1.88495592 meters per second squared. But just simplify it to 1.9 due to significant digits. So now you gotta multiply that by 75, and you get that the force of the spring would equal about uh about 1.4 times times 10 to the third excuse me 10 to the third power. There's something on my computer, so I'll just put 141 points newts, and those are your two answers. But those are my two answers. I don't know about yours, but those are my two answers for this problem. And see you next time. Please don't forget to dislike.